Example 10. A 75-pound load is supported by an angle bracket, pulley, and cable as shown in the figure. Determine A. The force exerted on the bracket by the pin at C and the reactions at supports A and B of the bracket. Okay, so what we're going to do would be we will first isolate this part here, isolate this part, and we will create its own free body diagram. And then next would be the angle bracket. Okay, so we draw the free body diagram first. Okay, this is our uh pulley. Okay, and then at the edge we have a 75-pound force going down straight down, 75 pounds. Okay, at a certain angle here as well, we have our tension, right? And the ratio is provided, that is 4:3. Okay, so 4 here and then 3. So it means this part here is 5. It's a 3, 4, 5 triangle. And then this is the center of our C, right? And the radius would be 3 inches. Okay, this is 3 inches. Since we have isolated the pulley and our pulley is pin connected, so we have an a y component of our C, and by inspection, only T has an X component, right? And it is going to the right. So therefore, to counteract that, we must have a force going to the left. So this is to the left our C sub X. Okay. First, we must quantify the value of our T. Now, we already did this in our previous example. So summation of moment at C is equal to 0, assuming counterclockwise positive. Now, our 75-degree angle creates a counterclockwise moment, right? So that is 75 positive times 3 minus our tension, our cable, T times 3. Now, of course, it was already mentioned that we will not utilize the angles 3, 4, the ratio 3, 4, 5 because our cable is applied perpendicular to our pulley, right? And its perpendicular distance is equivalent to the radius of our circle. So that is 75 times 3 minus t times 3 is equal to 0. And then therefore t is equal to 75 pounds. Right. So therefore, another way of looking at this is that if you are pulling uh your rope, no matter how far you make that the orientation of where you are pulling your rope, same ra gud na siya gihapon ang iyahang tension within that rope, right? So mo na siyang 75 ang ato ang value for our tension. Okay, so knowing that our value for our tension is 75, then we can now quantify our C sub y and C sub x. So we do force summation y is equal to 0, assuming upward positive. And the only upward force is C sub y. So that's C sub y minus our 75 minus our y component of our tension, and that is T times 3/5. So that's T times 3/5 is equal to 0. So C sub y is equal to positive 75 plus 75 times 3/5. C sub y is equal to 3 divided 5 times 75 plus 75 is equal to 120 pounds. Now, if you want to use angles, walay problema, you can do so. But please be very careful that if you want to know this angle here, let me zoom in more. This angle here, so that's 3 over 4 rather than 4 over 3. Because 4 over 3, it refers to this angle, right? Okay, so please be very careful. So since we have calculated our C sub y now, we do summation of forces x is equal to 0, assuming to the right positive. So to the right is the x component of our tension. Tension, that is 4 over 5. So that's T times 4/5 minus C sub x is equal to 0. So C sub x is equal to 75 times 4 over 5. 4 over, then this is equal to 4 divided 5 times 75. That is equal to 60 pounds. C sub x. And since we are tasked to find for the force exerted on the bracket by the pin at C, so we will be calculating the magnitude of our force applied at C. And that is magnitude. Okay. That is C is equal to the square root of C sub x squared plus C sub y squared is equal to the square root of 60 squared plus 120, right? 120 squared. So our value at C, the force, is 60 squared plus 120 squared is 18,000. Square root answer, it's 134.1640786 new pounds. Okay, so that is the reaction at C, the force exerted. Now, if we are to this, our C sub x is going to the left, C sub y is upward when we are evaluating the free body diagram of our pulley. Now, if we are to find for the values of the reactions at supports A and B, therefore we will change our uh, direction of our C sub x and C sub y accordingly. So let us do our free body diagram of B. So if this is our bracket, so that's 18 inches and 10 inches. Okay, so this is our bracket, 18 and then 10. Okay, so we have C, we have A, and we have B here. This is 18 inches. Okay, and then from here to here, this is 10. And if you can observe at B, that is a roller, right? It is not pin connected. It only rests at at B. So it means it only can resist normal force B sub Y. And since A is pin connected, so that's A sub Y. And then let us assume that our A is to the right, A sub X. Okay, now, like I said, for letter C, our C sub X is going to the left, C sub Y is going up. And if we do our analysis now at our bracket, we must present our C sub X and C sub Y opposite to the initial orientation. That is, for our C sub X, instead of going to the left, it is going to the right to maintain equilibrium. And then for our C sub Y, instead of going up, it's going down, C sub Y. Now, why is this? Now, like I said, if sa kaning una na to nga figure, ihang force is to the left, if pag-isolate na po nato, if to the left ra gihapon siya, so ni-move siya padulong sa left ang imong structure. Right? So like I said, in order for us to maintain equilibrium, it must be, there is cancellation of forces by virtue of Newton's third law of motion. Right? So that is why C sub X now, if when we do our analysis in the bracket, follows the opposite direction na. Okay. So if in order for if we do force some sorry, if we do force summation in the x, we can immediately calculate for our a sub x. However, if we do force summation in the y, we'll end up with two unknowns, that is a sub y and b sub y. So what we can do is we do moment summation at a, since our c sub x is given man. Okay, so that is summation at moment a is equal to 0, assuming counterclockwise positive. Okay, a b sub y causes a counterclockwise moment about a, right? So that is positive b sub y times its perpendicular distance, which is 10 inches, and then c sub x clockwise moment, so that's c sub x times 18. And then, of course, we will not be able to consider c sub y because the line of action of c sub y passes through point A. So that is equal to 0. Then b sub y is equal to c sub x times 18 divided by 10. We substitute the value of our c sub x, and that is 60. So this is 60 times 18 divided by 10. So our b sub y is equal to 60 times 18 divided by 10. That's 108 pounds. Our b sub y. So knowing b sub y, we can now do our force summation. Okay, let us start with our x. Summation of forces x is equal to 0, assuming to the right is positive. So that is a sub x plus c sub x, right? Because again, c sub x now will be to the right in order for us to have an equilibrium at our pulley. Okay, since when we did our analysis in our pulley, c sub x is to the left. And when we did our analysis in our bracket, we assume that our a sub x is to the right, but eventually we will learn that dili di is equal to 0. So a sub x is equal to negative c sub x, which is a sub x is equal to negative 60 pounds. So therefore, A sub x is equal to 60 pounds to the left. Or we write arrow. Okay, this is our A sub x. Then for our A sub y, summation of forces y is equal to 0, assuming upward positive. Okay, so we have, if we look back, only A sub y and B sub y is positive. It's going up. So that is A sub y plus B sub y minus C sub y is equal to 0. So A sub y is equal to C sub y minus B sub y. And then we substitute our values. C sub y is 120. B sub y is 108. So that's 120 minus 108. So A sub y is equal to 120 minus 108. That's 12. 12 pounds. A sub y. So our reaction at the magnitude of at A, magnitude of reaction at A is equal to square root of A sub x squared plus A sub y squared is equal to the square root of A sub x. That would be 60 squared plus 12 squared. So our A is equal to 60 squared plus 12 squared. Let's take the square root, that is 61.188233416 pounds. And its direction of reaction A, that is theta is equal to tangent A sub y over A sub x. Now for my A sub x, I will not be using the negative, but it is understood that it is going to the left. So that is equal to tangent A sub y is 12 over 60. So theta is equal to 12 divided by 60. 12 divided by 60 is 11.3099327327 3247 3247 degrees going up to the left. So this is how we do our analysis, especially if there are more than one rigid body involved. That's example number 10.